We will continue with the convergence of the series. The next example is summation n equals to 1 to infinity, n times natural log of n over n plus 2 cubed. This is a little bit harder problem in the sense we have to go through two-step process. So when you look at the problem, what you have to think about first is what we can do is the fraction. And what can be the best and simplest fraction to be related to with this fraction? So as we have been doing, we will just ignore the lower degree term. So the numerator is has one term, so we leave it as it is. And the denominator, that is degree 3 polynomial. So we just make a n cubed and ignore any other lower degree term. We don't have to expand all those. So that is approximately similar if n is very large. So when we simplify this fraction, what we get is natural log of n over n squared. Okay. So what our strategy will be, we will show that this one converges, and then we will bound this fraction with this fraction to show this one converges. So let's show summation n equals 1 to infinity, natural log of n over n squared converges. So we want to use integral test. So we will think about 1 to infinity, natural log of x over x squared dx. What you notice from here is derivative of natural log is 1 over x, but denominator is x squared. So you cannot use a substitution method. So instead of using substitution method, you will use integration by parts. We always put natural log of x as u, and then dv equals x to the minus 2 power dx. And du equals 1 over x dx, and the v equals minus x to the minus 1 power, right? And so this is original, and we did like this. So this is an improper integral. So we will put integration, the t goes to infinity, integration 1 to t, natural log of x over x squared dx. So this becomes limit t goes to infinity. So this times this one will make natural log of x times minus 1 over x, because this is minus 1 over x, minus integration, this part, minus 1 over x times 1 over x dx. Right. From 1 to t. So that becomes limit t goes to infinity, negative natural log of x over x minus minus is plus integration 1 over x squared. Dx 1 to t. So that equals limit t goes to infinity, minus natural log of x over x minus 1 over x 1 to t, because this is the same as this. So we have to evaluate this. Then it becomes limit t goes to infinity minus natural log of t over t minus 1 over t minus natural log of 1 over 1 minus 1 over 1. So natural log of 1 is 0. And when t goes to infinity, 1 over t goes to 0. So we have limit t goes to infinity minus natural log of t over t plus 1. So minus minus will make plus. And then we will use L'Hopital's rule, because both numerator and denominator goes to 0. Then we have 1 over x on the numerator and denominator is 1 plus 1. So when t goes to infinity, it is t, right? 1 over t. So t. So t goes to infinity, this part will go to 0, and that is 1. Therefore, summation n equals 1 to infinity, natural log of n over n squared converges by the integral test. Any question? The next one is show the given series n equals 1 to infinity, n times natural log of n over n plus 2 cubed converges. At the starting point, what we did was we thought this one, the given terms are approximately similar to natural log of n over n squared. But indeed, we are adding the positive terms in the denominator because n is greater than or equal to 1 with positive numbers. And so denominator is smaller as the bigger on the left side. And that means 1 over something will be smaller. Moreover, n is greater than or equal to 1. When we multiply them, it will make the numerator also bigger. So this one is n times, we want to think about n times natural log of n. So that was natural log of n over n squared, n. It was, I think, cubed and then squared. So actually the same. So denominator is larger, and so the fraction, entire fraction is smaller. So in this case, by the comparison test, the given series converges. Because summation n equals 1 to infinity, natural log of n over n squared, which is larger, that converges. So any question? This time, let's consider summation n equals 1 to infinity e to the 1 over n squared. Again, we want to use comparison test because what we know about this one is bounded. If we limit ourselves for n is greater than or equal to 1. So what's going on here is 1 over e to the 1 over n squared. We want to think about the exponential functions graph. This is y equals e to the x. And we want to think about n equals 1. So n is greater than or equal to 1. Indeed, if n is greater than or equal to 1, then 1 over n is less than or equal to 1, right? And so that means this is a power. And x equals 1 here. And then this one is e to the 1 power, right? And so all the values, when we plug in any n greater than or equal to 1, the value will be less than or equal to e, right? So that is less than or equal to e to the 1 over n squared, which means e over n squared. Any question about this? So that is bounded with this one. And what we observe here is e is a fixed number. So summation n equals 1 to infinity, e over n squared converges by the p-series test. If you want, then you can mention integral test also. So by the comparison test, this is greater than or equal to 0. Summation n equals 1 to infinity, e to the 1 over n squared converges. Any question? Let's do the next problem. So summation n equals 1 to infinity, n over n plus 1 to the n squared. So obviously the power has n, so we have to use the root test. So we will consider n equals 1 to infinity, nth root of absolute value an, and then that is limit n goes to infinity, n over n plus 1 to the n squared to the 1 over n power. So limit n goes to infinity, n over n plus 1. We just calculate this part, then that is n squared over n, which is n, right? So n over n plus 1 to the n power. So that is more or less familiar. That is how the number e is defined. So limit n goes to infinity, n plus 1 over n to the n power equals e. So what we want to do is we want to regard this one as 1 over n plus 1 over n to the n, because those are reciprocal. So this one is goes to e, right? And so that the limit will be 1 over e, and that is greater than 1. So 1 over something will be less than 1. Any question? So that is less than 1. Therefore, n equals 1 to infinity, n over n plus 1 to the n squared converges by the root test. Any question? The next one is about summation n equals 1 to infinity, 1 over n plus n times cosine squared of 2n. So cosine squared of 2n is bounded by 0 and 1. So let's start with cosine of 2n. That is a cosine function, so that should oscillate between 0, -1 and 1. But if you think about cosine squared of 2n, then when we square here, and then the squared, 1 squared, the largest number squared is still 1, right? But cosine squared is positive or 0, so it should be greater than or equal to 0, right? So cosine squared of 2n is bounded by 0 and 1. So when we think about the denominator, n plus n times cosine squared of 2n, that is bounded by n plus n. So because this one is less than or equal to 1, so that is 2n. And then when we think about 1 over, so 1 over n plus n times cosine squared of 2n, and then that is greater than or equal to 1 over 2n. So if a cosine appears, then you would think about just bounded by 1. And then think about what is going on with this one. And then it is 1 over 2n, and then probably it will diverge. So summation n equals 1 to infinity, 1 over n plus n times cosine squared of 2n diverges by the comparison test. So it is important to know which test you have to use when you look at the series. The next question is limit n equals 1 to infinity, n plus 2 over 6 to the n power. This time we want to use the ratio test. Because of n plus 2, we cannot use the root test. Ratio compares the adjacent term an plus 1 over an. And then we can rewrite that as limit n goes to infinity. Absolute value of an plus 1 times 1 over an. So that becomes limit n goes to infinity. An plus 1 is n plus 1 plus 2 over 6 to the n plus 1 times 1 over n. We flip it, then that is 6 to the n power over n plus 2. So that is limit n goes to infinity. So n plus 3 over n plus 2. We just combine dig2 and dig2, and then 6 to the n power over 6 to the n plus 1 can be written as 6 to the n times 6. So dig2 will cancel each other, and this part will go to 1. So that means everything will converge to 1 over 6, that is less than 1. So summation n equals 1 to infinity, n plus 2 over 6 to the n power converges by the ratio test. Any question? So we have only 2 sections to go, and we will have enough time, and then we will do the review for the final. That is very important to review to prepare for the final exam. Summation n equals 1 to infinity, square root of n squared minus 1 over n cubed plus 6 n squared plus 5. So whenever we have this type of fraction, I said you can forget the lower degree term and then just think about the higher degree term and see what could be the closest fraction to the given fraction. So square root of n squared minus 1 over n cubed plus 6n squared plus 5. That is approximately square root of n squared over n cubed. So the square root of n squared is n over n cubed, which is 1 over n squared, if n is large. And then those are approximately similar. And so probably you can imagine that this should be convergent, right? Because this series will converge. But to argue rigorously, this one must be less than this one. Otherwise, we have to think about the ratio between these two. So if you look at the given fraction, then that is square root of n squared minus 1 over n cubed plus 6n squared plus 5. And we want to compare that with just n over n cubed plus 6n squared plus 5. And then obviously this one is larger because n squared minus 1 reduce the number, right? So, and then we think about dropping this part. Then we have n over n cubed. And we are adding positive number in the denominator. So the entire fraction will become smaller. So this fraction in the middle is less than n over n cubed, which is 1 over n squared, the same as this. Since summation n equals 1 to infinity, 1 over n squared converges by the p-series task, the given series converges. The larger one converges, and this is greater than 0. So this series will converge by the comparison test. So the next section is about the power series. Power series looks like this. We think about the variable instead of the concrete number. So n equals 0 to infinity. Cn, this is the number, and x to the n power. X is a variable. So it can be written as C0 plus C1 x plus C2 x squared plus and so on. That is a power series. And the Cn is coefficient and the x is variable. And that is called power series. And there is a variation of power series. N equals 0 to infinity, Cn times x minus a to the n power equals C0 plus C1 x minus a plus C2 x minus a squared, That is power series in x minus a and power series centered at a and power series about a. Okay, this is how those series are called. This time, what we want to think about for what x value the series will converge. So x is not a fixed number. There is a flexibility in x, and we want to think about the boundary of x, where which makes the given series converges. So the next question is for what value of x does the series converge? Summation n equals 0 to infinity n factorial times x to the n power. Again, we may think about root test, but because of n factorial, we cannot do it. When that is the circumstance, we can consider the ratio test. So we consider limit n goes to infinity, an plus 1 over an. So that becomes limit n goes to infinity, an plus 1 is n plus 1 factorial times x to the n plus 1 power over an is n factorial times x to the n power. So we already know that that can be written as limit n goes to infinity. We are so n plus 1 is n plus 1 times n factorial over n factorial. And then the second one is x to the n plus 1, so x to the n times x over x to the n power. So those two will cancel each other, and these two will cancel each other. So we consider limit n goes to infinity, n plus 1 times x. And so whatever the number x will be, it is infinity if x is not equal to 0. So by the ratio test, the series diverges if x is not equal to 0. And the series converges only when x equals 0. That's what we have been saying. Let's do the different pattern of problem. The next one is summation n equals 1 to infinity, x minus 3 to the n power over n. So an equals x minus 3 to the n power over n. Limit n goes to infinity, absolute value of an plus 1 over an. And that is limit n goes to infinity, an plus 1 times 1 over an. So limit n goes to infinity, an plus 1 is x minus 3 to the n plus 1 over n plus 1. And then an, 1 over an is n over x minus 3 to the n power. So limit n goes to infinity, these two combined, so n over n plus 1. And of course, when you combine these two, you will get x minus 3, right? So x is a random number, but anyway, that is just a random fixed number, and n varies. When n goes to infinity, n over n plus 1 will go to 1. So that means that goes to absolute value of x minus 3. So this is a series, and when we think about the ratio test, to make the series converges, this value must be less than 1, right? So if absolute value of x minus 3 is less than 1, then the series is absolutely convergent. So in other words, this one can be reinterpreted as x minus 3 stays between -1 and 1. So we add 3 on each side, then we get x is less than 4 and greater than 2. The second case is when n equals this absolute value becomes 1, that is inconclusive case. So we have to check case by case. If absolute value of x minus 3 equals 1, then we have x minus 3 equals 1, or x minus 3 equals minus 1. So in this case, we just add 3 on both sides, then x equals 4, or we add 3 on both sides, then the other one will make x equals 2. So we have to check a little bit more. So if x equals 4, then summation n equals 1 to infinity, x minus 3 to the n power over n will become summation n equals 1 to infinity, 4 minus 3 to the n power over n. So that means that equals n equals 1 to infinity. 1 to the n power is 1 over n. So this is a harmonic series which diverges. However, if we think about the case when x equals 2, then summation n equals 1 to infinity, x is 2 minus 3 to the n power over n. So summation n equals 1 to infinity, 2 minus 3 is minus 1 to the n power over n. So this is alternating harmonic series, which we know that converges. So by this analysis, what we can conclude is the series converges when x is between 2 to 4, but when x equals 2, it converges, right? And so we have to add this boundary, but we have to omit the boundary, the 4 in the interval. So if you want to present that as interval, then open bracket 2 to 4, close parenthesis. Any question? So we will do up to this amount, and then I will do one more example, and then I will talk about the general statement tomorrow. So currently what I'm doing is completely different from the previous ones related to integration. So even if you didn't do well with the integration part, you still can do the exam 4 very well. And I think if you do exam 4 very well, and if you follow me for the final exam review, then you will be able to effectively prepare for the final. Of course, you have to review the exam 3, but the all 4 exams given in the during the semester. But final exam problems may be a little bit perturbed. I mean, it's not. It doesn't have to be just number changes. Though the number changes the previous exam problem. But as long as you attend all the sessions for the final exam review, you will be able to know how to prepare for the exam, and so you should be good at the final exam. So do your best, and you don't have a lot of time. It's just about 1 month until the final, and so just you should have enough energy because you are young. And so do your best and see you tomorrow.